Today in class we started the mole, but we did just the smaller, easier mole problems. The mole is you're going to see is not going to be this ugly little creature, but rather a unit, a really important unit that we use in chemistry. So before we began the problems, we got some vocabulary. So if you want to pause the video and record these vocabulary words into your notes, that would be great. We're going to be talking about atoms. When we talk about atoms, we're going to be referring to individual elements like zinc, and that would be an atom. If we're saying ions, well, we're going to be talking about what's in an ionic compound, such as if we had magnesium bromide, would be made of one magnesium ion and two bromide ions. So ions are going to make up what's in an ionic compound. And the word molecule and the word formula unit, these two are just terms that we use for compounds. So when we talk about compounds, again, a compound is made of more than one element. We're going to either use the word molecule or the word formula unit. What's the difference? Well, a molecule is going to be for covalent, and that's going to be two nonmetals. And the word ionic is going to be a metal and a nonmetal, such as sodium chloride. If you have an NaCl, you have a salt or sodium chloride formula unit. And if you have water, two nonmetals, you would have a water molecule. It's just a unit. Technically, all four of these are units that we're going to be looking at. We're going to abbreviate molecule MC just to make it easier, and we're going to abbreviate formula unit FUN. So the ionics are FUN, and the molecule are covalent. You can remember because it's got a C in it. Alright, we're going to go ahead and begin the math. Well, no, before we're going to do some examples. Aluminum is Al, and Al is going to just be an atom because it's just an element. Magnesium bromide, because it has a metal in it, we use the oxidation numbers, and we have to switch those oxidation numbers. So this is an ionic compound. It does have ions in it, but because it's ionic, we're going to call this a formula unit. These are two nonmetals, dinitrogen trioxide, so N2O3, and so therefore this would be a molecule because this is covalent. We don't switch the numbers on covalent. If it's got a metal in it, we're going to use the oxidation numbers. This ATE ending means it's one of those polyatomic ions. That's a -1. So this is going to be CaNO3, and then it would be a 2. And this is an ionic compound, so therefore it's going to be called a formula unit. Just like we're all humans, and we have males and we have females, these are all compounds and made of more than one element, and so they're either going to be called a formula unit or a molecule, depending on if they're ionic or covalent. So that's not hard. So the mole, again, you can pause this, is for our vocabulary. Special unit we use in chemistry to measure, and the key word in here is the amount of substance. For example, 1 dozen means that you have 12 things, whatever you're referring to, whether it be atoms, molecules, formula units, donuts, or roses, you'd have 12. Well, if you have a mole of something, you have 6.02 times 10 to the 23rd, things that you can count. And that's a very big number, but it is how many you have. This is referred to Avogadro's constant. Mr. Avogadro here is the gentleman that is responsible for that. It's not just a made-up number. There is a real chemistry reason behind it. I won't go into that during the video. Alright, so to begin a problem, you're going to always find your number. And so there's my number. And we're going to start with our number. You're going to find the unit right behind the number, and this particular unit is moles. Moles abbreviation is just MOL. You could put the ES if you want. And also you need to know a label. A label is going to be what substance are you referring to. And we are talking about silver. So we need a number, a unit, and a label. You're then going to put that over 1. You're going to draw your dimension analysis table. Now this unit and label are going to travel here. We don't move the number doesn't move. So we've got the unit and we've got the label. And we are looking for atoms. That's our other unit of silver. The mole is our base unit, and it can take us anywhere we need to go. So we want to take it to atoms, and then we're going to take it to atoms of silver. So I took my number, my unit, my label, I brought it down, and what I'm looking for is going to the top. Now for now, the conversion that we're going to be using is 1 mole is 6.02 times the 10 to the 23rd of counting things, such as atoms, molecules, formula units, etc. So notice that 1 is with the word mole. So 1 will always be with the word mole. It won't always be on the bottom, but wherever mole is to the left should be a 1. And what does 1 mole equal? It equals 6.02 times 10 to the 23rd power. Alright, so these will cancel. And so in your calculator, you will multiply, because they're both on top, 3.65 times 6.02 times 10 to the 23rd. I would suggest, especially with the little calculators, that you always put your scientific notation stuff in parentheses. So we're going to multiply. You get 2.197, etc., times 10 to the 24th. We want 3 sig digs. So there's 1, 2, 3. This is 2.19. So this is actually going to round to 2.20 times 10 to the 24th. And then my unit would be atoms of silver. And the reason it's atoms is because silver is just an atom. Our next example is we now have 0.943 moles. Here's my number. Here's my unit. But this is a compound. So because it's a compound, it's either going to be a formula unit or a molecule. So aluminum's a metal, so I need to find its oxidation numbers, and I'm going to be switching. So we have 0.943 moles, my unit. Aluminum as a 1, nitrate 3 on the outside. So I've switched those oxidation numbers, 1 being right there. Now I'm going to bring down mole, aluminum nitrate. And this time I'm looking for formula units. So those are fun. Aluminum nitrate. Notice that aluminum nitrate is going in 3 boxes. Wherever mole is, he always gets a 1, and 1 mole equals 6.02 times 10 to the 23rd. Again, because they're both on top, I would be multiplying, and I'm going to get 5.68 times 10 to the 23rd formula units of aluminum nitrate. Alright, our second question here we do in pre-AP is having us break down into these formula its individual pieces. Okay, so in a piece, in a formula, it's got 1 aluminum and it's got 3 nitrates. So every formula that I've got is 1 aluminum and 3 nitrates. The question says, how many nitrate ions do we have? So for every formula that I have, I've got 3 nitrates. So to answer this question, I need to take my number of formulas or molecules, depending on if it's ionic or covalent. In this instance, it's formula, and multiply by the individual pieces. So in this case, I've got 5.68 times 10 to the 23rd formulas, and I'm going to multiply by the individual pieces, and I'm looking for nitrate, so it's 3. So I'm going to multiply by 3, and this would get us 1.70 times 10 to the 24th nitrates. so I don't have to set it in a table. Now I'm still same problem, still working. I'm not starting off with atoms, so I can't go directly because this is a compound. So this is what making this one different than the first one. So again, here's my formulas. So I'm going to take my number of formulas and I'm going to multiply by the individual pieces. Well, in a formula, there are 9, because 3 times 3 is 9 oxygen atoms. So I'm going to multiply by 9. So I'm going to take that 5.68 times 10 to the 23rd and multiply by 9 to figure out how many oxygen atoms. And there are 5.11 times 10 to the 24th oxygen atoms. If I wanted to do nitrogen, there are 3 nitrogens. I'd multiply by 3. If I wanted to do aluminum, I would multiply by 1, which I'd get the same answer. So again, to find those individual pieces, you need formula units or molecules, and then you just multiply by the individual part. You may want to write this down in your notes somewhere, because that might be helpful. Okay. On your note page, this should be superscript. It says 1026. I forgot to superscript the 26. So unless I've corrected on your sheet, so we're going to go 7.74 times 10 to the 26th power. Our unit is not moles this time, it's molecules, because we're dealing with covalent water. If we let the table lead us, we're going to bring molecules down. We're going to take it to the mole of water. Molecules down, moles, because that's what I'm looking for. There's moles. Moles gets a 1. Okay. So this time, and again we want to put parentheses, this time, and I might want to just have you always put parentheses. You don't have to physically do it on your paper, but make sure you do it in your calculator. This time, instead of multiplying, because this number's on top and this number's on bottom, we are going to divide. So I'm going to take this big number and divide it by this big number. Your calculator gives you something that looks like this, and some bunch of numbers after it. I don't remember the numbers after it. We're going to round this, so we could do it 2 ways. We could put it in scientific, or we could just round it for sig-digs. This is 3 significant digits. To make this have 3, we could round this to 1,290, and then that would be the moles of water. Or you could do scientific if your calculator's in scientific, and it would be to the 3rd, and again it would be moles of water. Either one is fine with me. You can put them all in scientific or not. Alright, so now we're looking for, still continuing, so we're looking for how many hydrogen atoms. Well, we've got water, so for every molecule of, whoa, don't know what happened there. So for every molecule of water, there are 2 hydrogen atoms. So I know I need to multiply by 2, and I know I need to multiply not the formula units because this is covalent. I need to multiply the molecules by 2. Well, this answer is not molecules. That's mole. So my molecules are up here in this problem. So I need to multiply this by 2, because for every one of those molecules there's 2 hydrogen. So I multiply that by 2, and I get 1.55 times 10 to the 27th. Whoops. I meant to write hydrogen atoms. That's a lot of hydrogen atoms. But honestly, we wouldn't be able to see those. It's a gas, but in the grand scheme of things, it's really not a lot of hydrogen atoms. Okay, so now we move on. Next, we're going to talk about if we had a dozen, we'll just say elephants. That's what I used in class because it's my favorite. You would have 12 elephants. That's a lot of elephants. But if I had a dozen elephants, it wouldn't weigh 12 grams. So a dozen means you have 12 quantity. It doesn't mean they weigh that. So in your notes, if you will write this rule, nothing will ever weigh 6.02 times 10 to the 23rd. So when we talk about weight, which is grams, you're never going to use Avogadro's constant. Instead, you're going to use the molar mass. And we did the molar mass very recently. So let's begin. It says how many grams are 0.320 moles of silver nitrate. Silver is Ag, so positive 1. Nitrate's NO3, negative 1. So our formula is AgNO3. So we're going to begin. You will have mole, AgNO3, and we'll put that over 1. We'll bring mole down, and I'm looking for grams of silver nitrate. Okay, so when we begin, when we find the mole, wherever the mole is, it gets a 1. But because this is grams, I cannot use Avogadro's constant. So what we're going to use instead is the molar mass. So we're going to come down, we're going to write our symbols, and we're going to count. There's one of those, 3 of those. We're going to go to the periodic table. Silver is 107.9. We're going to round to a tenth spot. Nitrogen is 14.0. And oxygen is 16.0. We're going to multiply. These are ones, so we get 48. And then we're going to now add these numbers together. Get 169.9. This will now go up here. So 169.9 will go with grams. It's really grams per mole, but you can see grams per mole right there. So it is this many grams per 1 mole. So you can always stick it in the dimensionalist table with the word grams. So let me get the circles and stuff off of there. So we're going to put it here. And now, because they're both on top, we're going to multiply. And so we get 54.4 grams of silver nitrate. Okay. All right. Next one. Kind of flipping it on you. I think your note page says 145. So 145 grams of sodium sulfate. This is a plus 1. That's a minus 2, and I've swapped them over 1. We're going to bring down grams this time. Again, I'm just following the table. And this time I'm looking for moles. So mole has popped itself on the top. Because it's on the top, it will get a 1. I would usually use Avogadro's constant, but because this is grams, we're going to use molar mass instead. Thing's not going to let me go down, so I'm going to come over here to the side. Sodium, there are 2 of them, and it weighs 23. That's 46. Sulfur, there's 1, and it is 32.1. And then oxygen, there are 4, and that is 16. 64. Sorry, I'm writing small there. And we'll add those together. We'll get 142.1. And this time, instead of going on top, because mole's up there, it's going to go on bottom. And so this time, instead of multiplying, we are going to be dividing. So 145 divided by 142.1, you get 1.02 mole Na2SO4. And so these are the 2 types of one-step problems. You're either going to convert them to things that you can count, and you'll use Avogadro's constant, or you'll be converting with grams, and you don't use Avogadro's constant. You use molar mass instead. So our last page are the answers to your homework. So you can pause this and write those down or keep it up. I also have put it on the PowerPoint. It is on the last part of the PowerPoint. So you can pull up that slide on the PowerPoint and have the answers as well. Okay, good luck.